Today, I would like to show you how we can use 3D modeling from landscape change analysis. Uh, I have chosen an area has that is affected by open pit mining activity uh, and by heavy industry. So, if we have a look on the map where it is, so we are here in the middle of Europe, in the Czech Republic, and we are exactly at this location, right? Here we have open pit mining brown coal, and if you look at aerial image, so here we can see power plants that are burning brown coal and turning it into electricity. So one is here, and the other one is here, okay? And the other one is here. So uh, here is the brown coal. It, you see it, this is the old pit that is moving towards the city. The highway was moved so enlarge they can enlarge mining all the way here. The brown color here is the actual brown coal that's being mined here. And then we have this water reservoir. It's called Nechranice Water Dam. It's one of the longest dams in Central Europe, and this water is used for the heavy industry, for the chemical plants. It's used for other hydrological recalculations in the region to support with water. If we have a look here, very close here, as it's called Lake Moss. It's all here. It's a former open pit mine that has been turned into a hydrological recalculation, a leisure time recalculation. So now it's like a lake uh, for swimming, bathing, and recreational purposes, which is nice. And the water from that Nekranice water dam is fed in here. If you look in the past, okay, we can do it in the GIS then. So now I'm in the GIS. I will add a new map. And I will add a base map showing the same, but it was faster to show you that mappy.cz server. I changed the coordinate system to our national coordinate system. And here we are then. We water them, the open pit mine, and if we look on some other data, so I just go to catalog, and then I am go to portal, and I will try to search for some layers in ArcGIS Online or Living Atlas. I would like to try to search for military survey if you can find it. No, here, I'm looking for. No, I can't find. Never mind. So I will search for an artificial. Oh, sorry, for an old orthophoto, which is here. I cannot add it. Why? Finally. So if we now compare two layers, you can see that the river is the same. Here the river is meandering the same, but in 1950s there was no water then, right? Same here. There are no signs of mining activity. All you see are small fields and agricultural land, right? So here has happened a very dramatical landscape change where a lake or and water reservoir was established and open pit mine uh, started, right? So uh, to do to do this, so now I will have a look on the data I have prepared for landscape change analysis, right? So I have here data from all map. I have here contour lines from 1953. So these contour lines, they correspond to this orthophoto. So they correspond to they correspond to the shape of the original landscape. See, they are describing the meanders of the former river, and they are describing the landscape. So these are the contour lines, and I have here as well the texture for the 3D model to be created. Here we have textures. So here is the texture. And I have here as well data from laser survey. And okay, these data are related to the laser data are from 2013. So I have the corresponding orthophoto is from 2011, but it doesn't matter that much. So here I have the orthophoto, and I have here the DEM is already integrated, right? So, now I would like to do the landscape change analysis. I will try to do it in ArcGIS Pro, and some steps I will be showing in the old ArcGIS or the old ArcMap, because especially the transects that are part of analysis are hard to be carried out in ArcGIS Pro so far. Okay, so at first, I will have a look on the old data. So I turn all this off, and here I have the contour lines. Here I have the contour lines. I can open attribute table. But I have to check prior interpolation. I have to check where the elevation information is stored in the attribute. So here, okay, these are national data. So Vishka means elevation in English. So these are the elevations I will be using, right? These contour lines were hand digitized from an old map. I'm not sure if this based on works. I can have a look. I can, if it's working. Sometimes this layer doesn't work well for me. Yeah, here we are. So this is the old map from 1950s. Actually, this map is, or the elevations are derived based on the photogrammetrical survey of these images. So it should be corresponding. If we zoom in there, so you can see that the contour lines are hand digitized and the attributes were in hand transformed to the corresponding lines. I don't know why is the map so blurry, but it's a tile survey, so I think there's something wrong with the tiles ArcGIS survey, so I have to check this on later. But anyway, this is the way how we do this. We take an old map, we georeference it, right? And then we manually digitize the contour lines to receive the digital lines with elevations, and now we are going to turn them into the corresponding digital elevation surface. So these maps I can turn off. At first, I will search for interpolation functions. In the previous videos, we've been working with different types of interpolation functions. So at first, I use the topo to raster function, which is here. So input layer are my contour lines. Field will be the value the size visca, so elevation, and type is contour. Output surface will be creating the outputs. I call it EEM 90s, right? And the cell size I can set to measure. Yeah, they are like very sparse, these contour lines, but that's a problem for maps because if you like to do the georelief reconstruction and we rely on old maps, is a problem to get a proper maps, right? And if, let's say, I know these are the only maps describing this region with contour lines before the big landscape change, so then we have no better data than this. Okay, so for the water dam itself, we can get more detailed data from the water management companies. I can show you later. But for the whole basin and the mining side, it's not easy to get such data. So, okay, we say that we do 10 meters pixel. It's not that good, but we can let it run it. In the meanwhile, I will try to search. For the old map of the water reservoir. I can show you. Hopefully, I can find it. This one. So see, here we have it. Here we have the map. You can see the former water stream. The red lines here are showing the dam, and then we have here contour lines that are more detailed than the ones I have. You see they have 1 meter interval. But I can tell you that I did scientific research on deposits on this reservoir, and we have tested the quality of these data, of these base map I'm showing right now, and they are not very accurate. So if you are more interested about reading about the reconstruction of the water reservoirs, here I have this research I did a year back, a dynamic of sediments in reservoirs inflows, case study of Skalka and Ekarita reservoirs Czech Republic, where we deal with different methods of landscape reconstruction and bathymetric survey of the bottom of the reservoirs, dealing with the sediment transportation stuff. So it's a bit more advanced, but anyway, it deals exactly with the topic we are right now working with. So it means that these data, even if they are sparse, they are representing the bottom of the reservoir. And then if we do the bathymetric survey, it means if we go there with a sonar, then we can have a look on the data, or we can have a look on the landscape change in the matter of sedimentation. So this is the pre-dam georelief, and if we go there surveying with boat and sonar, and we get a new data from the sonar, then we can distinguish, or we can say what is the sediment thickness. It's like in this image. If I try to enlarge it, so you can see this is the dam elevation in 1955. It's a more precise digital elevation model than more. It's a more detailed digital elevation model that was in like in my GS right now. These are data gathered by sonar survey, and here you can see the differences. So here in the inflow we have 15 meters of sediment, right? Which is a lot. On the other hand, here 4 meters are missing. Uh, they were washed away, or the sediment was washed away, right? So just a little different topic, because now we are working in more general way, just trying to see the overall landscape change. So I will turn off these maps. I have here now the DEM that I have created from the contour lines. You can see here that the contour lines are missing because the maps we were digitizing were not available for this area. And the interpolation is trying to figure out how the landscape looks like here. So these data are just made of nothing, but the interpolation tries to do its best, right? So now we can have a visual check on the data. We've said that a very simple visual check on data is the hill shape function. We just run the hill shape. So Raster will be the EM1950, and we make it the EM1950 shaded, right? You run it. And here we go. So that's our hill shape. The resulting grid size is 10 meters, which is not very detailed. So if we zoom in, we are losing the detail, right? We can see the squares, but anyway, it's a good it's a good visualization of the pre-industrial georelief. You can see that no signs of mining. Here we can see the former valley of the river, right? And now we have a look on the contemporary surface, the one obtained from the laser data. So this one. Again, I run the hill sheet analysis. So I here we say it's DEM 211 shaded. We keep the visualization parameters as they are. And so here is the resulting data. You see, so these data are from laser scanning. It means they're very detailed. You can see a lot of from the mining. I just wait to my slow computer loads it. So here you can see a deposit where they were storing the ashes from the burning, coal burning process or from combustion process. Here we see the water and a lot of other details concerning the former river channel, etc. So, and if we just compare it one over the other, so I just move to appearance and swipe. So you can see that the river valley corresponds, right, to the data. But here is the landscape totally changed, right? So, so the very simple analysis how we can distinguish the changes, the landscape changes, as the subtraction analysis. It means if we take if we take wait, I can try to draw. So here we have the former landscape, right? If we something like this, then here is the valley, right? That's the former landscape. Then we have here the contemporary landscape, right? And it looks something like this. Then we have this turn the same, but then here we go to the mining site, right? And here we have these steps in the mining. And then this is the same, then is the flat water level, and then is the same again. Hopefully, hopefully you can see the difference, right? And now if we do the landscape change analysis, so here this is gonna be the difference, right? So if I take the former georelief and I subtract the current georelief from the previous, that I no sorry when I take the contemporary and I subtract from it the former georelief, so I got the minus values. It means that it was mined away. And here I will have positive values because the water level is here. I don't have the bathymetric data right now, so I will just deal water and the former pre-dam georelief, right? So for here, we can use a raster calculator. There's a function called raster calculator, where we can build expressions working with the grids, right? But just for this simple analysis, we will use very sophisticated function that's called minus. So it just subtracts the two layers. So we said that first we take the uh, the current layer minus the EM 1950, and we say it's just minus, called minus. And here we are. Here we have the minus. So the biggest difference is minus 156 meters. So it means they have mined off 150 meters. They have removed. That's a lot of soil, right? And here you see that we are reaching somewhere 90 meters that has been added. These are the deposits. This visualization is not very clear. I will run the old ArcMap and I'll show you this visualization in ArcMap because I'm not sure if we can do this in the Pro or actually I didn't find the proper way how to do it. Or I will show you how it should be in the old ArcMap, and then I will try to get as close as possible in the Pro. Okay. So here we are in the old ArcMap. I like it very much. So I open the data I have just created. Okay. There's the minus. Okay. So most of you are familiar with the old ArcMap. If not, it's pretty the same as the Pro, except we don't have the ribbons, which I don't like, and everything works with the right mouse button. The menus are with the right mouse button. So I go here and I open properties. And here I have symbology. It's like the symbology here, right? Minus and here appearance and things. Here is symbology. The same is here symbology. Okay. So here I choose scrambling. I say I want 3 intervals. 3 intervals, right? And I say that values from 10 to minus 10 are okay, no change, because the data are not very, let's say the old data are not very precise. So I say that the added value will be blue, subtracted will be red, and here we go to white. It means it will make such a nice scale, right? Oh, oh. And here, now here we see the biggest changes, okay? If I add the texture below, we can compare it. So minus, so you see that the differences here. This has been mined away. This has been mined away. This area was added, or like a deposit. This area was added. This area was added. This was added, and here we have the water added. Right. The water level is not corresponding to the water body boundary because we've made this plus minus 10 meters, so maybe we should make it more accurate. But anyway, This is the type of visualization that is showing us the biggest changes in the landscape that has happened in the past. If we use more sophisticated softwares, or we can compute the volume. It's called cut and fill. It's implemented in the ArcGIS as well, but I have never found out how it works. So I'm using the Surfer software where I can compute the volumes very precisely. It works on that. It just overlay the two surfaces in 3D and computes the cut and fill volumes. You see cut. This is like the cut, and this is the fill. Cut and fill volumes. We can try to compute it. If we can search it, but I haven't used this is ages in the ArcGIS. Volumetric analysis, polygon volume, surface volume. So it's here. Calculate the area and volume of the region between a surface and a reference plane. That's what we like. So our input surface then is the ground. Above the plane is the reference plane. I but this works only not with the two layers, but it works with just with the plane with defined elevation. So this is going to help us. Yes, this is what I'm looking for. It's a current field. So this is the before raster surface. That's what I'm looking for, and this is after. And this is the raster. And let's have a look how it's gonna make. Cut fill. We can have a look how it works because I'm not sure it says. Before and after and out raster. Okay. So it's gonna. We can try it and have a look what it's gonna do. so so here we have it, and it just says that net loss, net gain. If you look to attributes, so here we have here is some values of the volumes and stuff, right? But further study of this function is required to understand the exact values, which is not the focus of this exercise right now. But anyway, this is another type of analysis, but we cannot define the zero unchanged value because you see unchanged is nothing here. So what next is then we try to do the same visualization as I did in the old ArcMap. So we take the minus, we look into Symbology. We should be able to change the color scheme, and there should be possibility to format the color scheme, right? But I haven't found out how to say because I just have here the whole range, but I don't have here, but I don't have here the values. Uh, I don't have here. I don't see the exact value, so I don't know where is the zero where I can. You see, I just percentages, and I am not sure to. I just cannot say where is the zero to make it white, right? You know what I mean. So I'm unable to make the same visualization as the old ArcMap. So the other way how we can visualize the changes are the transects, right? A transect is a line that's going across the terrain, and it then is turned into a 3D line and is visualized as a graph. So this should be possible to do here. Choose this and turn this off so it's not distracting us. And here we should be able to create uh, no we are not, but if you would like to create a profile graph, then in the old ArcMap is very easy. I just add the DN215. Right, that's this one. Minus I can take away. I add here the DE1950. I open the 3D analysis. I open the 3D analysis window and just I choose the proper DEM. I like to draw a line, interpolate line. I just draw it like this. And I create a profile graph. Voila. Here's the profile graph, right? Going from the mountains across the valley. If I choose the same for the new data, draw a similar line. I have a look on the profile, and here we are, right? Here you see the mining site, then the deposits, and here you see the flat water body, and here we go. If I choose, both of the lines, then I can overlay them and see how they are different. You see here, no change. Former landscape, mining pit, former landscape, deposits, added, then similar landscape, then the water body, the former valley, then similar landscape. So this is a pretty good visualization how we can overlay these two graphs. Okay, this was let's say this when we draw these lines by hand, they are not very precise because I draw it by hand. But I can draw it by a line, then I can interpolate shape, and then from 1950 and from 211, and I have two identical lines interpolated from different terrains, and that is very precise. But this is fast. It's just if you like to find a path in the terrain, or if you're doing research and you quickly like to draw profiles, this is the best way how to do this. And if you like to make nice graphs, because I agree that the graphs from ArcGIS are not very fancy, and you can do right click, export, or native, or data. You can as a text, or you can do the preview, and here you do raw data. You can just copy paste into Excel or whatever and do fancy graphs you like. And you can mesh up different types of graphs from different sources, or if we are doing this bathymetric and graph penetrating radar surface, we can put all the data together and visualize them. This is a problem in the Pro. We are not able to do this very well, but we do it as follows. At first, because there is no option to draw adjust this line, it has been promised to add it in the upcoming version of the Pro. I'm not sure if I have the latest version. I can have a look. Yeah, I have the latest version, so G72. And if I would like to draw, the profile, then I have to go to catalog. I have to go to folders, search for my folder. Here I just create a new shape file, right? It will be called profile, just a profile. It will deploy line. With this in my local coordinate system. Here we are. Now I will draw a line. So I just define it in the similar way we did before. I save it. And then I will use a function that's called interpolate shape. Interpolate shape, right? It means I will take input surface, let's say the 211 DM. Input feature will be my profile. We'll call it profile 211. Sampling distance is just get it. We do run. And the line will be interpolated. If you look at my original profile in the attribute table, then you see is a polyline. And if you look in the profile 211, it's a polyline ZM. It means that it has been interpolated. It's now it's a 3D line, right? And now we should be able, I hope it will work, otherwise I will be like a clone. Now, okay, I select this line, and if I go to data, now we can see that we can do a profile graph. So you see, now I have sorry, I have gathered the profile graph as here, but here it was a matter of 2 seconds. Here it took me half an hour of analysis to get this one. We can export it, but we can export it as a graphic. I'm not able to export it as Excel. Here I can define some basic properties. So in a way it works, but it's very cumbersome. And able to put two lines in one graph, like I did it here. I cannot compare two graphs in one, right? Which is problematic. But anyway, we are glad this is implemented so far. I've seen somewhere another way how we can visualize these graphs. I will give it a try, but um, please don't promise much from this my attempt because I have read this in some blog. What was uh, incorporated in the ArcGIS Pro, right? So here in the scene, now we are turning from the analysis because these are two ways how we can analyze the changes with the minus analysis and then with the profile graph or the cut and fill analysis. So now here, I bring in the DM in the scene, and as we are in this working in the scene, then you see that I have here 2D layers and elevation surfaces. Elevation surface is giving the elevation to 2D layers. So it means if I like to make a 3D visualization of anything, then the visualized layer has to be floating on the elevation surface. So I take this one and I bring it. Yes, this is the ArcGIS Pro problem. I don't know why this is happening. Okay, so we give it a try. We can say that maybe it doesn't have just define coordinate system. So define coordinate. Maybe there's a problem. So we say that this one has this coordinate system. It's running well. We do the same for the for the autophoto. Okay, now we can give it a try again. Now we can see it here. It was before it wasn't visible. Now maybe we can move it. Yes, now it works. So there was a problem with the coordinate system. And now when I bring in the texture, then the texture is going to be floating on the elevation surface, right? You just have to wait till my computer computes it. And now we have it here, right? And it should be like 3D. It's not much of 3D, but okay. We can go to appearance. Can we do the exaggeration somewhere? Properties. No, we can do this here. Never mind. Anyway, so here now we are in 3D. Like very basic and simple 3D visualization, right? And there should be implemented the function in this indices, hopefully. No process. No, sorry. So I thought that it's gonna be here, but it's not here. And here was somewhere the button to create the elevation, which is not currently here. Maybe I bring in here again. I told you this is gonna be just an attempt to do it. Because this tool is not located in imagery but in analysis, in exploratory 3D analysis. Here's a cut and fill, line of sight, and here is elevation profile, right? So now I just should draw the line. And now it's calculating the interactive profile. Just give it a second. Where it is. Yeah, here you go. So you see it. Here we have this profile. You can see it's like interactive profile. It's going from the first line as I'm moving on the profile, the blue dot is moving on along the line I did draw. So that's nice, right? If I just turn this off, wait. So here we can see on the real terrain, right? But this profile is just like this. And here we have another exploratory analysis, which is for instance line of sight. It's a nice analysis. It just computes if you just stand somewhere and it computes what area you are able to see, right? But if we would like to do some kind of visualization, turn this off. If then we can make it as a video, like a fast animation. There is a lot of options concerning the animations in the ArcGIS Pro. You can find an online course focused on this in the S3 training. Here I will just briefly show you how we can do this. Here somewhere should be. I have always problem finding because it's a very tiny icon. Where it is. I said it's a very tiny icon. Here is an animation in Add Animation. So, and if we add an animation, then here we got a lot of different options how to animate. If we do it fast, then we can circle around the center maybe. It will define the animation somehow, or we can extend it, let's say, for 12 seconds, and if we run the animation, then just the animation turns around, right? For 12 seconds. Now, if I delete the keyframes, you can see we can append keyframes. So you can define a keyframe like this, then we zoom in, do another keyframe, then we turn it or move it. We append another keyframe, so you can define the keyframes. You can define the keyframes based on your predefined positions, right? Now, if we try to run this animation, so it's just following. It's following your keyframes. It's not moving very well on the stream, I see. But you can check it on the video then. Okay, and then when we are done, we can just export it and to make a movie. So that's all I wanted to show you today regarding the landscape change analysis. I hope you did enjoy it, and see you at my next video then.